Hello everyone, welcome to the Makari Virtual. Hope you are doing good. Today I am going to start with a new topic that is memory hierarchy. In the yesterday's class, I have finished with your fifth chapter that is optimizing the program performance. And today I am going to start with a new topic that is memory hierarchy, or what are the contents of the memory, what are the tools available in the memory, and what are the types of memory. So these are the main topics of the today's content. But before that, let's take a quick review what we have covered in the yesterday's class. So let's take a quick review of the yesterday's class, that is previous class. In the previous class, we have studied about the optimizing the program performance. Then, what are the learning objectives that we achieve while performing the or while attaining the or while getting the PPT's presentation? We can predict the performance of the parallel program. That is, we can predict what are the performances or what are the output of the parallel program whenever we execute more than one program at the same time. Understand the barriers to the R performance. That is, we can understand the barriers or the hindrances that is available to the high performances. So the main objective or the learning objective is, first of all, we can identify what are the performances or what is the performance of the parallel program and understand the barriers or the hindrances that is used or that affects the multiple parts or that affects the performance of the program. One is outline. Now, what we have studied in the last class, that is SPEEDUP, superlinearity issues, SPEEDUP analysis, cost, efficiency, Amdahl's law, Gustafson's law, Amdahl's effect. So these are the topics which we have covered in the yesterday's class. SPEEDUP, that is used for showing the or measure the running time that is used during the parallelism. That is, when more than one program are executed in parallel or executing in parallel, that what is the speed effect or what are the measures or what are the techniques that is used to measure the speed, that is known as the SPEEDUP. This is the example or this is a formula that is used, that is TS divided by TP, where TS is the execution time on a single processor and TP is the execution time on a parallel processing or parallel computers. This is a formula that is used for SPEEDUP in terms of running time, in terms of theoretical analysis. This is the diagram or this is the formula that is used. This is the theorem we have studied about the parallel computing or parallel program. This is which we have covered in the last class. What is the formula, how it can derive, and what is the motto, what is the outcome of this method. Then SPEEDUP analysis, that is, we can analyze after analyzing the or after measuring the speed of the parallel computer or parallel processor. That is, when more than one processor are executed at the same time, then what is the speed or how we can analyze the speed of the parallel computing or the parallel processing. These are the analysis that is used, that is omega and P equals to TS divided by TP. This is less than, greater than, equals to. Then we have also studied about the diagrammatical representation for the execution time for the parallel portion or the parallel processing. That is, this is the time, these are the processor. This is the time that starts from 0 and ending with the last one, and these are the processor. This is one processor, another processor, another processor. These are the multiple processors and these are the time units. This shows non-trivial parallel algorithm computation component as a decreasing function of the number of processors used. This is the time for computations, that is what is the time or what is the time required for the different processors. This is the execution time. This is the time for the communication. So one is the time for communication, one is the time for execution. Now this slide shows the combination of the time of the execution as well as the time for the communication. This is we have discussed in the last class. This is performance metric component. We have discussed about the algorithm. What are the metrics used for the algorithm or for the programs? There are two types of algorithm or metric used. One is known as parallel running time and another one is known as parallel execution time. And they have the same meaning. Now, next is your cost. How we can calculate the cost? By using the formula that is cost equals to parallel run time into number of processors. That is what is the running time, that is the running time that runs in the parallel multiplied by the number of processors. That is how many processors are used for the parallel computing. Suppose I am using 5 computers in a parallel way. So I am using the number of processors, that is 5. So cost equals to parallel running time into number of processors, that is 5. The cost of a parallel algorithm should be compared to the running time of a sequential algorithm. This is what we have studied about the comparison between the cost of the parallel system, cost of the sequential algorithm or sequential system. This is cost optimum. This is parallel cost equals to OFT. This is the formula or this is the theorem that we have studied in the last class. Now, in the next slide shows the Amdahl's law. This is one of the important laws that we studied in the last class. That what is the Amdahl's law and how it will achieve or how it will show the different operations in the computation. So this says, let f be the function of operations in a computation that must be performed sequentially, where 0 is less than n or 0 is less than 1. The maximum speed achievable with n processors is, this is the formula that is used. This is a formula that is Ep is greater than Fts plus 1 minus Fts divided by n. This is the proof of the Amdahl's law. This is the proof that we have discussed in the last class, that is Amdahl's law. These are the questions. Where is the assumption? The assumption is used by the Williamson and Allen. This is the Amdahl's law, that is 1 by f. Now, next we have also studied about the consequences of the Amdahl's law, that is limitation to the parallelism. These are the limitations of the Amdahl's law. Then we have studied. These are the limitations, and then we have discussed about the examples. That is what examples of the Amdahl's law or how we can calculate the Amdahl's law algorithm. This is the best example of the quiz. This is the Amdahl's effect. This is shown by using the diagram or by using the graph. This is the review of the Amdahl's law. Then we have also studied about the ISO efficiency metric. That is, what is the terminology that is used for the isometric or ISO efficiency metric. What are the terminologies that is used? One is parallel system. Next is scalability of a parallel system. Next, scalable system, and then ISO efficiency. These are the annotations that is used in the ISO efficiency, that is N, P, T, omega, phi, K, sigma. And these are the description of these one, that T0 is the total time spent, T0 equals to, this is the formula, this is the ISO efficiency relationship or relation. How we can derive, these are the main steps that we have discussed. We also discussed the deriving isosufficiency relationship. This is the usage. Next, we have discussed about the scalability function. That is how we can use the scalability function and what is the formula that is used by the or that is used as the scalability function. This is the meaning of the scalability function. This is the diagram that shows that we can maintain the efficiency beyond this memory size, but cannot beyond the memory size. This is the example that we have discussed in the last class. These are the examples. Then we also talked about the summary, what we have covered, that is performance terms, running time, cost, efficiency, speed up. Then we also studied about the model of speed up, serial component, parallel component, communication component. These are the factors that prevent linear speed up, that is serial operations, communication operations, process startup, imbalanced workload, architecture limitation. This is what we have covered in the last class. Now let's start with the new topic, that is chapter number 6, memory hierarchy. This is the chapter name, that is memory hierarchy. It contains 7 topics. First topic is your storage technologies, that is what are the techniques or what are the technologies that is available for storing the data. That is what are the types of memory, because memory is the same as the storage. So storage technology or the memory technologies are the same thing. So if I say storage technology or if I say memory technology, both have the same meaning. Then second topic is locality, how we can locate the things or how we can locate in the disk storage. Then memory hierarchy, what is the hierarchy of the memory, how we can differentiate between the memory, who is the highest memory, which memory has the highest priority, which memory has a low priority. So these are the memory hierarchy topics. Then cache memory, that is what is the cache memory, why we require the cache memory, advantages of cache memory, limitations of cache memory. Then fifth point is writing the cache friendly code, that is how to write the cache code that is in a C language or in a C++ language, that how to write the cache code. Then putting it together, that is impact of caches on the program performance, that what is the requirement of the cache or how we can give the impact or how we can use the cache memory to increase the or decrease the or to maintain the efficiency of the program or increase the program performance. Then seventh part is the summary. So these are the 7 chapters that we will discuss in this. These are the 7 topics that we will discuss in this chapter, that is memory hierarchy. Now let's start. This is, to this point in our study of systems, we have relied on a simple model of a computer system as a CPU. That is, we rely on the CPU that executes the instructions and the memory system that holds the instructions. So till now we have discussed or we have relied on these systems, that is CPU and the memory that is used to hold the instructions and data. In our simple model, the memory system is a linear array of bytes. The memory system is a linear array, that is a sequential array of bytes in which we can store the bytes, we can use the bytes, we can give the or store the bytes in an array format in a linear fashion or in a sequential fashion. And the CPU can access each memory location in a constant amount of time. While this is an effective model as far as it goes, it does not reflect the way that the modern system really works. In practice, memory system is a hierarchy of storage devices with different capacities, cost, and the access time. So, memory system is a hierarchy of the storage devices, that is, it contains multiple parts or multiple types of the storage devices with different capacities. That is, there are different capacities of the memory like 256 MB, 128 MB, 512 MB. The next one says CPU registers hold the most appropriate or most frequently used data. Small fast cache memory nearby or memories nearby the cache act as the staging area for the subset of the data and instruction that is stored in the relatively slow main memory. So there are different types of memory that we have used in the computer system to store the data, to fetch the data, to execute the data. So let's take with the help of PPT that what are the types of memory and what is the memory hierarchy. So this is chapter number 6, that is the memory hierarchy. Now, what is the main objective of the class, or what is the main objective of the today's class? That is study about the various types of memory. That is, what are the types of memories, or what are the different types of memories. Next, memory hierarchy. This says the memory unit is an essential component in any digital computer system. As I told you, memory unit is an essential component or the important component in any digital computer. Since why it is needed? Because it is needed for the storing of the programs and data. Now, what is a program? That is used for the execution. That contains some instruction. That is a set of instruction. Data means on which we can perform the operations. Suppose if I will write, or I have wrote 2 plus 3, that is your data. And if I write 2 plus 3, 3 plus 4, 5 plus 6 in different instructions, that is a program. So memory unit is an essential component of the computer system that is used to hold, or that is used to store programs and data. Next point says, not all accumulated information is needed by the CPU at the same time. That is, not all the information, or not all the together information, accumulated information is needed by the CPU at the same time. Therefore, it is more economical to use low-cost storage devices to serve as the backup for storing the information. So, therefore, it is very cheaper, or it is very economical to use the low-cost storage device, so that we can take the backup, or we can use the backup for storing the information that is not currently used by the CPU. So, this slide says CPU does not require the data at the whole time of the execution. It requires some time, at another time it does not require. So that transferring of the data, or that movement of data, or storing the data that is not used by the CPU is stored in the memory. That's why we require the memory, because the data is not required at all the times by the CPU. It has to be stored in some area. That area is known as the storage. Then next point says, or the next slide says, computer memory hierarchy is a pyramid structure. That is, it is available in a pyramid form that is commonly used to illustrate the significant differences among the memory types. That is, it is used, or it is generally used to illustrate or describe the significant differences, or the differences between among the different memory types. So, memory hierarchy is represented in a pyramid, and it shows the difference between the memory, like primary memory, cache memory, secondary memory. Next one says, the memory unit that directly communicates with the CPU is known as the main memory. So the first type of memory that directly communicates, that is internal, that is known as the main memory. Next one says, devices that provide backup storage are known as the auxiliary memory. So that is a device, or the memory that provides the backup for the memory, or that provides the backup, is known as the auxiliary memory. Then next one says, the memory hierarchy system consists of all the storage devices employed in a computer system, from the slow by high capacity auxiliary memory to a relatively faster main memory, to an even smaller and the faster cache memory. So this says there are two types of memory generally, main memory and the secondary memory, that is auxiliary memory. Main memory is internal to the memory or internal to the computer, and the auxiliary memory, secondary memory, is external to the storage or external to the computer. And there is one more memory that provides the high capacity or that provides the high speed of access, that is known as the cache memory. So cache memory lies between the CPU and the main memory, where access time is too slow, that is required to execute the programs in an easiest or the simplest or the fastest manner. This is a memory hierarchy. This says memory hierarchy is to obtain the highest possible access speed while minimizing the total cost of the memory system. That is, it is to obtain, or memory hierarchy is to obtain the highest possible access speed. That is, what is the highest speed that is used for memory or that is used for accessing and or fetching the instruction from the memory or storing the instructions into the memory, while minimizing the total cost, that is the total cost that is required, that is we can minimize, or the main target of the memory hierarchy is to minimize the cost of the memory and the speed of the memory is faster. This is the diagram. This shows the diagram, that is main memory, auxiliary memory, cache memory. This shows three types of memory in this diagram generally. On the left hand side, it is auxiliary memory. The examples include magnetic tape, magnetic disk. There is one input-output processor that is used for giving the input and taking the output. That is your input-output processor. Then this is your main memory. This is your cache memory. This is your CPU that interact with the main memory and interact with also the cache memory. But it cannot interact with the auxiliary memory. That is because these are the internal memories. Main memory and cache memories are the internal memory. So CPU always, or CPU at every time interact with the main memory and the cache memory. Now let's see. First of all, if the CPU fetches the instructions and it finds the data, or it finds the data that we need it for execution in the cache memory itself. So simply CPU fetches the data, do the processing, displays the output. But if cache memory does not contain the data that is required by the CPU, then CPU approaches to the main memory. When it or the CPU approaches to the main memory, if the content is available in the main memory, then it transfers the data to the CPU, and then CPU performs the operation and gives the output. So if the data is available in the cache memory, it will pass to the CPU. So at this time, the speed of the access or the execution speed is faster. Why? This is very close to the CPU. That is, cache memory is close to the CPU as comparison to the main memory. So it performs the operation, gives the output, do the calculations and everything. This is the input-output processor that interact with the auxiliary memory and the main memory. This is CPU. This is also CPU that interact with the cache memory. Then this is the hierarchy that is represented. One is registers, then cache memory, main memory, secondary memory. Secondary memory includes, or auxiliary memory includes, two parts, that is magnetic disk and magnetic tape. So this is registers, cache, main memory, secondary memory. The main memory occupies a central position. This says this occupies a central position by being able to communicate directly with the CPU and with auxiliary memory devices through an input-output processor. This slide says main memory interact with the CPU directly and interact with the auxiliary memory, secondary memory, with the help of input-output processor. A special very high-speed memory that is known as cache is to increase the speed of the processing by making current programs and data available to the CPU at a rapid rate. that is, it can execute, or the cache memory is used to execute the instructions in a fastest way as comparison to the main memory. This is a special memory that is known as cache is used to increase the speed of the processing by making the current data or the program available to the CPU at a rapid speed or at a fast speed or a high speed. So this diagram shows main memory, CPU, and how main memory interacts with the auxiliary memory with the use of input-output processors. Input-output processor includes use for inputting, that is input the data, and give the output, that is output processors. There is also a new memory that is used for fastest processing, fastest fetching, fastest input and the output, that is known as the cache memory, that lies between the main memory and the CPU. This diagram shows the cache memory, main memory, CPU, input-output processor, auxiliary memory. This is the memory hierarchy again. CPU logic is usually faster than the main memory access time, with the result that processing speed is limited primarily by the speed of the main memory. That is, CPU is fully dependent or wholly dependent on the main memory. Why? Because all the data is contained in the main memory. So, with the result that its speed is primarily affected or depends on the speed of the main memory. Then second point says the cache memory is used for storing the segment of program, that is used for storing the data of the program or the segment of the program currently being executing by the CPU. That is, the cache memory is the internal memory that is attached to the CPU and used for storing the segments of the program, that is parts of the program that is currently being executing by the or executed by the CPU, or that requires frequent the temporal result, frequent information, present calculation, or the high-speed calculation. Then the typical access time ratio between the cache and the main memory. So this slide or this point shows the relationship between the cache memory and the main memory. So cache memory is more faster, that is 1 to 7. If the cache memory is 1, then the main memory is 7. So it shows that access time is very high between the cache memory and the main memory as compared to the main memory. Next point says auxiliary memory access time is usually 1000 times that of the main memory. That is, it is usually more or the high speed as compared to the main memory, that is auxiliary memory, that is secondary memory is 1000 times higher than the or more or the speeder than the main memory. This is the pyramid or the memory hierarchy that shows in a pyramid format that what are the contents of the main memory or what are the contents of the memory hierarchy. This pyramid shows the memory hierarchy or what are the parts of the memory. First is your CPU, that is processor register. This is your CPU or the processor. This is super fast, super expensive timing capacity, that is CPU and the processor register. Next element, one is your CPU, next element is your CPU cache. That is, there are different types of cache memory like L1 cache, L2 cache, L3 cache. L means level, level 1 cache, level 2 cache, level 3 cache. This is faster, expensive, small capacity. In the same way processor, that is register, it is super fast, super expensive, tiny capacity. This is faster, expensive and the small capacity. Next, these are the next is your physical memory, that is your main memory, that is the best example is RAM. That is fast, reliable, reasonable, price reasonable, average capacity. Example includes EDU, SORAM, DDR RAM, RORAM and much more. So This is the main part. That's why it is lies between the in between the cache memory registers and the main memory and the secondary memory. That is, it is used for storing the data and the instructions in the main memory. Then next is the solid state memory, that is non-volatile memory, that includes SSD, flash drive, average speed, price reasonable, average capacity. Then at last, virtual memory, that is mechanical hard drives, that is slow, cheap and the large capacity, that is used for using the backup or for taking the backup. So this is a memory. These are different types of memory. That's why it is known as, this pyramid is known as the memory hierarchy. Then main memory, that is most of the main memory in general is made up of the RAM. Now, this slide shows the main memory topic, that is what is main memory and what are the types of the main memory. So main memory is the internal memory, that is the base memory or the basic purpose memory that is used by the computer for executing the instructions, for executing the programs. This is the main purpose, or it is a general purpose computer that is made up of RAM, integrated circuit chips, but a portion of memory may be constructed with ROM chips. That is, a computer is made up of multiple RAM chips, that is multiple RAM integrated chips, but some chips are using, or some chips are of the ROM chips, that is a ROM type. So main memory is divided into two parts, that is RAM and the ROM. RAM is random access memory and the ROM is read-only memory. In the same way, RAM is also divided into two parts. One is known as static RAM, another one is known as dynamic RAM. This is the RAM, that is random access memory. In this, we can write the data, we can read the data. That is, we can write or read both from the RAM. One is only ROM, that is read-only memory. We cannot write the data, we simply read the data from the ROM. And RAM is divided into two parts. There are brief category, that is of two parts. One is static RAM and another one is dynamic RAM. This is a RAM chip is better suited for communication with the CPU if it has one or more control input that select the chip when needed. So this says a RAM chip is more better or the most suitable for communication within the CPU. That whenever CPU wants to insert the instructions or wants to execute the instruction that is used for communication, that is done by the RAM chip. If it has one or more control input that select the chip when needed. The block diagram of a RAM chip is available. The capacity of the RAM chip or the capacity of the memory is 128 words or 8 bits, that is 1 byte per word. This is your RAM. This is your RAM chip, that is chip select 1, that is chip select 1, chip select 2, that is CS2, read operation, write operation. This is your address part, that is 7-bit address. And the RAM chip is of, it is says 128 words of the 8 bits, that's why it is written as 128 into 8 RAM. This contains 8-bit bus system. This is the RAM chip. Then next one is your table that shows multiple combination, that is CS1, CS2. These are the bits available. These are the read and write operations. And this is the memory function and this is the state of the data bus. This is the comparison of the static RAM and the dynamic RAM. This is transaction per bit, that is static RAM is 6 and the dynamic RAM is 1. That is, static RAM is more faster than the dynamic RAM. Then access time, static RAM is 1x and the dynamic RAM is 10x. That is, it is 10 times faster than the dynamic RAM. Then persist, static RAM is persist, that is, it is constant, or static RAM is constant, while dynamic RAM is not constant, that is no. Static RAM is not sensitive, that it is not vanished or it is not destroyed, deleted whenever we touch the RAM. But yes, it is dynamic RAM is sensitive. If you touch, then it will be destroyed. Then next is your cost. Static RAM is more costly than the dynamic RAM. That is 100 times costly than the dynamic RAM. Then applications where it is used. Cache memory, static RAM is used in the cache memories, while dynamic RAM, that is DRAM, is used in the main memory or the frame buffers. So this is a comparison based on the access time, based on the persistent, that is constant, based on the sensitivity level, based on the transaction per bit, based on the cost, based on the application. So next is your detailed with version or the detailed slide of the RAM, that is read-write memory, that initially does not contain any data. The computing system that is usually stored, that is used in usually stores data at various locations to retrieve it later from these locations. That is, RAM is used for storing the data, so that it is used by multiple processor or it is used by multiple data or multiple locations, so that it can be used at the later stage. Suppose if I am using or if I am storing the data, that is I know that is later used for computation, that is for scientific calculation. So I can store the data in the RAM. Next point says its data pins are bidirectional, that is data can flow into or out of the chip via these lines as opposed to those of the ROM that are output only. Then next point says it loses its data once the power is removed. That is, RAM is a volatile in nature. It loses the content when the power is turned off. Next point says it has a directional select signal RW, that is read write W. When RW equals to 1, the chip gives the output of the circuit, and when the RW, that is read write, is 0, that it inputs from the rest of the circuit. Then RAM types, that is of two types, one is static RAM, another one is dynamic RAM. Then this is the detailed version of the static RAM. This says each cell stores bit with the 6 transistor circuit. Then it retains the value indefinitely as long as it is kept power. That is, its data cannot vanish, its data is constant until the power is off. Relatively insensitive to disturbances such as electrical noise. It is not affected by the external environment. Next, faster and the more expensive than the dynamic RAM. It is more faster, but it is more expensive than the dynamic RAM. Then dynamic RAM, this says each cell stores bits with the capacitor and the transistor. So there is no limit that 6 transistors are used, 5 transistors are used, but this says it has a capacitor as well as the transistors. Value must be refreshed every 10 to 100 nanoseconds or microseconds. So in this, the data is retained indefinitely, that is till the wrong time until the bar is turned off. But in this, value may be refreshed every 10 to 100 microseconds. Then it is sensitive to the disturbances, that is external environment. Then it is slower, it means dynamic RAM is slower and cheaper than the static RAM. This is your random access memory. Features: static RAM, dynamic RAM. The same concept. The basic storage unit is a cell, that is 1 bit per cell. Next is your ROM. Till now we have discussed about the RAM. Now next is your ROM, that is used, or ROM is used for storing the programs that are permanently resident in the computer and for table of constants that do not change in value once the production of the computer is completed. That is, it is permanently residing in the memory. It cannot delete it until we can delete the data or until when the production of the computer is completed. The ROM portion of the main memory is needed for storing an initial program. As I told you, we can use the ROM is used for storing the bootstrap loader. That whenever we start the program, there are few screens that are coming up that are stored in the ROM. That is known as the bootstrap loader, or whenever we initiate the or on the or access the computer, that activity or that program is known as the bootstrap loader, which is used to store the computer software operating when the power is turned on or off. Then what is detailed version of the ROM? That is, data is programmed into the chip using an external ROM programmer. The program chip is used as a component into the circuit. The circuit does not change the content of the ROM. That is, it cannot change the content of the ROM. Then it can be used as a lookup value or lookup table to implement the various functions. Used by the PC to store the information at the boot time. That is bootstrap loader. That is BIOS, basic input output system. Then next point says, when the power is removed from a ROM chip, the information is not lost, so it is a non-volatile memory. So ROM is a non-volatile in nature because its data is not removed whenever the light has or the power has gone. It has the OE, that is output enable pin, that is used to enable or disable the content of the output, content of the data. ROM types. What are the ROM types? There are 4 types of ROM. One is mask ROM, that is programs in data when the chip is fabricated. That it initializes the data or initializes the program and the chip is fabricated to initialize the data. Then PROM, that is programmable PROM, that is used by the user using the standard program or the PROM programmer by running some special type of uses. One program will not be possible to program it again. Then EPROM, that is erasable program, that whenever we write the program, it is stored in the chip. Then that chip is waste, because if that chip is filled, that data will not be removed, then that chip will be filled. But if there is a provision to erase the data, so that chip is also again used by the some other person or for some other purpose. So that is done by the erasable ROM. This is the chip that can be erased and chip reprogrammed. That is, chip can be reprogrammed. We can use the chip again. Programming process consists in charging some internal capacitors, the UV light that is used to erase the data. That is, we can put the chip in the sun that erase the data, and then we use the same chip for the another purpose, for storing the another program. Then next one is your double EPROM, that is electrically erasable PROM, that is used for removing the data with the help of electric currents. This is a ROM chip, that is CS1, CS2. Then what are the non-volatile memories? Dynamic RAM and static RAM, that is DRAM and SRAM, are the volatile memories. That is, it loses the data if the power is off. Then non-volatile memory, it retains the data even when the power is turned off. There are 2 types of non-volatile memory. That is, generic name is ROM, that is read-only memory. Misleading because some ROMs can be read and the modified. Next, what are the types of ROM? We have studied PROM, EPROM, double EPROM, flash memory. Then what is the firmware? That it is a program that is stored in the ROM. There are 2 types of program that is stored in ROM, that is boot time code or the graphic cards. Then next is the auxiliary memory. Till now we have discussed about the main memory, their types like ROM and the RAM, and there are multiple types of RAM also, ROM also. Now the next part is your auxiliary memory, that is your secondary memory. The main memory construction is costly, therefore it has to be limited in size. This says the main memory is of limited size because of the it is very costly. That's why we use the next memory, that is your auxiliary memory. Therefore, it has a limited in size. The main memory is used to store only instructions which are to be stored immediately. Hence, we require another memory, we require another storage that is used to store the program. The bulk of information is stored in the auxiliary memory. This is also known for the backing up storage or backing storage of secondary storage. So, auxiliary memory or the secondary memory is also known as the backing memory or the backup memory or the secondary storage or the secondary memory. They include, or the example of secondary memory includes hard disk, floppy disk, CD-ROM, USB, flash drives. This says when the electricity supply to the computer is off, all the data stored in the primary storage is destroyed. That is, whenever the electricity or whenever the power has gone, so the data will be vanished from the primary storage. But the data will retain in the secondary storage. The data stored in secondary storage can be stored in the for the desired time. Now, some tips for the auxiliary memory. This is the disk geometry. This is the disk that consists of platters, each with the two surfaces. This is the surface. This is the platter. This is the track. Each surface consists of concentric rings. These are the rings known as the tracks. This is known as the track, track 1, track 2, track 3, track 4. This figure shows track. Each track consists of the sector. So these are the sector. That is the again division of the tracks, again merging of the tracks, that is known as the sectors that are separated by the gaps. So this diagram shows the memory, that is disk geometry, that contains tracks as well as the sectors. This is the disk geometry with multiple platters, that is cylinder 1, this is one cylinder, cylinder 2, cylinder 3. These are also known as platters. This is the spindle. Then disk storage. This says disks are stored to store the, or disks are used to store the data, application software and operating system software. Whereas the primary form of storage in the earlier days of computing was magnetic tape, this has been replaced by the disk being medium today. The reason for this trend has been, that is why we moved from the tape to the disk, because of the decreasing cost per bit, reliability, reduced access time, higher transfer rate, reduced size, increase the capacity. Next point says, one trend during the past few years is a move of the optical storage medium. Many software companies offer both operating system and the application software on the optical medium, that is CD-ROM or DVD-ROM. Now, what are the storage technology that is used? One is your magnetic principle, that is based on the magnetic principle. Then data is also represented in the binary format, that is in form of zeros and ones. Then a rotating disk is coated with very fine ferrous oxide particles, each of which act and behave like a little magnets. Then next point says, all that is required now is a mechanism of converting the digital data of zeros and one into the magnetic states of north and the south poles. Next point says, in a storage disk drive, the mechanism which performs the function of converting the digital zeros and ones into the magnetic states, which can magnetize the surface area of the disk, that is known as the read head. And the write head is used to detect the magnetic states of the surface and convert them into the digital states. These are the disk capacities, that is capacity, that is maximum number of bits that can be stored, that is the capacity of the disk. This is Vendors express capacity in units of gigabyte, where 1 gigabyte equals to 10 power 9. Then next point says capacity is determined by these technology factors, or these are the factors that is used to determine the technology or the capacity. One of the feature or one of the technology that is used is the, or one of the factor is recording density, then track density, then aerial density. Next point says modern disk partition tracks into two disjoint subsets that is known as the recording zones. This is the computing disk capacity. This is capacity, that is number of bytes divided by sector into average number of sectors divided by track into number of tracks divided by surface multiplied by number of surface into platters. This is example, these are the capacities. Now, this is your disk operation. So first of all, let's take 5 to 10 minutes break and then come back, started with this topic, that is using the platters or using the disk operation. So first of all, let's take 5 to 10 minutes break. Then next is your disk operations, that is how we can perform the operation on the disk. Till now we have covered about the structure of the disk. Now what is the disk operation? So this is the disk operation. This is single platter view. The disk surface spins at a fixed rotational rate, that is it rotates at this level. Then this is spindle, this rotates, then spindle rotates, then spindle rotates. This is the rotation, that is the read-write head is attached to the end of the arm and flies over the disk surface on the thin cushion of the air. That is, first of all, it rotates from the right to the left or left to the right. By moving radially, the arm can position the read-write head over any attack or over any track. So this is move the track by positioning the read-write arm to the track. This is the read-write arm. This is moved to the next track. This is moved to the next track. This is moved to the next track. So it will move the tracks one by one. Next, this is your disk operation. This is a multi-platter. This is only one platter. This is a multi-platter. This is one arm. This is one arm. This is the one arm. Then disk access time, that is what is the time required or what is the average access time for the target, that is your time access. This is your T access, that is T average seek plus T average rotation plus T average transfer, that is equals to the T or the time access. Then there is a seek time or the rotational latency, that is the time taken to position the head over the cylinders containing the target sector. That is the seek time equals to 9 microseconds. Then rotational latency, that is the time for the first bit of the target sector to pass under the read-write head. Then there is a transfer time, that is the time taken to read the bits in the target sector. So these are the multiple disk access time that is used to access or that is used while we access the data from the disk. These are the examples. Then next part is your, or the next category of memory is your optical disk. This says the data is accessed from the underside of the CD-ROM. According to the initial specification devised by the Philips and Sony, data is broken up or data is given up into a stored in a single track which is embedded in a polycarbonate material. So whenever we store the data in the CD, it is stored in a or embedded in a polycarbonate material so that it can reflect from the side of the CDs. Then next point says the track starts at the inner of the disk and ends at the outer radius of the disk. So it starts from the inner and moves to the outer area. The track is comprised of indentations or bumps which are created on a master disk. The master disk is then used to create the actual CD-ROMs, that is the actual compact disk ROMs which are shipped to the customer. Next point says the laser beam is shown on the surface of the disk. The data is stored on a sequence of surface known as the lands and the feet. So this is the structure of the optical disk. The main crux is that it is starts from the inner part and moves to the outer part. It is based on the concept of the laser beam, that is where laser beam technology is used, and then light sensitive diode picks up the reflected laser light from the surface and converts to the digital data. This is the optical disc technology. Then next part is your DVDs, that is your digital versatile disc. This is the new standard or the new format that is available to offer high storage capacity as compared to the CD-ROM. Now, what are the difference between the CD and the DVD? The standard DVD holds 4.7 gigabytes or GB per layer. Dual layer single-sided DVD holds 8.5 GB on a single side. Error correction is more robust. That is, the error is mostly or the more frequently or the most appropriately rectified than the CD-ROM. Every DVD is a bonded disc composed of two 0.6 mm substances joined together. Then DVD uses MPEG technology for compression, that is motion picture expert group, for increasing or for compressing the quality of the picture. These are the multiple tape storage systems. One is your magnetic reel, cartridge tape, digital audio tape, that is DAT, digital data storage, that is DDS, digital linear tape, that is DLT. Next is your cache memory. So cache memory, as I told you, it lies between the main memory and the CPU. That is, it lies between the two memories, or it lies between the two terms, that is internal memory or the primary memory and the CPU. This says if the active portion of the program and data are placed in a fast small memory, the average memory access time can be reduced, thus reducing the total execution time of the program. Such a fast small memory is known as the cache memory. So the cache memory is the fastest component in the memory hierarchy and approaches to the speed of CPU component. This I have discussed already, that CPU is much faster than the main memory and the secondary memory. Next point says when CPU needs to access the memory, the cache is examined. If the word is found in the cache, it is read from the fastest memory or it is read from the fast memory. If the word addressed by the CPU is not found in the cache, the main memory is accessed to read the word. As I told you in the first few slides, that if the CPU is used to access the memory, then if the word is found in the cache, then the CPU fetches the data from the cache memory. But if the word is not found from the cache, then it is approached to the main memory to read the word. This is the performance of the cache memory, that is calculated by using the formula, that is hit ratio. Now, what is the hit ratio? When the CPU refers to the memory and finds the word in the cache, it is set to a hit. So whenever a word is found in the cache memory, then there is a hit. And if the word is not found in the cache memory, then there is a miss. So there are two concepts, hit and miss. So the hit ratio equals to hit divided by hit plus miss. This is the basic characteristics of cache memory is its fast access time. So the main feature of cache memory is that it is very fast in nature, or there is a fast access time of the cache memory. Therefore, very little or no time must be wasted when searching the covers in the cache. So there is no wastage over time whenever the CPU searches the content from the cache memory. Now, next is your important point, that is the transformation of data, that is transferring of data from the main memory to the cache memory. So whenever we transfer the data from main memory to the cache memory, it is known as the mapping. And there are three types of mapping techniques available whenever we transfer the data from the main memory to the cache memory. Now, what are the three methods or three mapping techniques? One is associative mapping, another one is direct mapping, next one is a set at associative mapping. So these are the three mappings available: associative, direct, set associative. Next, this is your cache memory. This is your diagram of the cache memory. Then memory address map. So mapping techniques are used to map or transfer the data from the main memory to the cache memory. But memory address map is a pictorial representation, that is, it is represented in terms of pictures to assign or of assigned address space for each chip in the system. So address map or the memory address map is a pictorial representation how we map the pictures or how we map from one memory to the another memory. To demonstrate an example, assume that computer system needs 512 bytes of RAM and 512 bytes of ROM. The RAM have 128 bytes and need 7 address lines, whereas the ROM have 512 bytes and needs 9 address lines. This is the mapping, that how mapping can be done between the RAM and the ROM. This is the explanation of the table. This is the memory connection to the CPU of the CPU. Then next is your associative mapping. This is the most reliable and the fastest technique of the organization that uses an associative mapping. It stores both the address and data of the memory word. This permits any location in cache to store an word from the main memory. Next point says the address value of 15 bits is shown as a 5-digit octal number, and its corresponding 12-bit word is shown as a 4-bit octal number. This is your associative mapping. This says a CPU address of 15 bits is placed or places in the argument register, and the associative mapping search for a matching content. If the address is found, the corresponding or the relative 12 bits data is read and sent to the CPU. If not, the main memory is accessed for the word. That is, if the address is found in the cache memory, then it is approachable, or the 12 bits are found or fetched from the memory and executes by the CPU. If it is not found in the cache memory, the main memory is approached for the word. If the cache memory is full, this says if the cache is full, an address data pair must be displaced to make room for a pair that is needed and not presently in the cache. That is, if the cache memory is full, so cache memory content may be deleted and then new content will be added in the cache memory. Next is your direct mapping. That is, associative mapping is more expensive. That's why we use the direct mapping. This is the direct mapping. Next is your set associative mapping. This is your direct mapping. That is, associative mapping is more expensive as compared to the RAM. In general case, there are 2 power k words in cache memory and 2 power n words in main memory. That is, 2 power k words available in the cache memory and 2 power n words available in the main memory. For example, k equals to n, that is 2 power n. K equals to n equals to 15, that is 2 power 15 words in the main memory. The n-bit memory address is divided into two fields, that is k bits and the nk bits for the tag fields. This is the diagram for the direct mapping. There is a tag, there is an index. This is the cache memory. There is a direct communication between the cache memory. This is the direct mapping. This is the direct mapping address. The disadvantage of using the direct mapping is that, first of all, the disadvantage of using SSAT mapping is that it is very expensive as compared to the RAM. Next, the disadvantage of using the direct mapping is that two words with the same index or the two words with the same inputs in their address but with different tag values cannot reside in the cache memory at the same time. Why they not reside in the cache memory? Due to the duplication, due to the redundancy. So the disadvantage is that no two words with the same index is residing in the computer memory to tag the values, to store the values. Next point says, set associative mapping is an improvement over the direct mapping. So there is an alternative approach that is used, that is known as the set associative mapping, that is improvement over the direct mapping in that each word of the cache can store two or more words of memory under the same index address. That is, we can store more than one word or we can store more than one word of memory using the same index, using the same index address. That is that limitation, that direct mapping address, direct mapping disadvantage can be reduced. That is the disadvantage of direct mapping. This is a diagram of the set associative mapping. Then in the slide, each index address refers to the two data words and their associative tags. These are a memory address and their tags. This is the 000, this is tag 1 and tag 2. Each tag requires 6 bytes and each data word has 12 bits. So each tag requires 6 bytes and each data has 12 bits, so that the word length is 2 into 6 plus 12, that is equals to 36 bits. So that's all for today's session. We have wind up the session. Yes. Now let's see with the help of book that what we have covered in the book. We will discuss about the cache memory, main memory, locality, static RAM, dynamic RAM. Then storage technology, what are the storage technology that is used? This says most of the success of computer technology system from the tremendous progress in the storage technology. Early computers has a few kilobytes of memory. The earliest computer PC does not have a hard disk. So these are the multiple storage technology like RAM, that is random access memory, that is of two varieties, and that is static and dynamic. This is static RAM that stores the bit in a bistable memory cell. This is inverted pendulum. Then dynamic RAM. This is conventional dynamic RAM. We have discussed about the dynamic RAM. This is memory modules. We have discussed about the modules. Main memory, dynamic RAM, static RAM. These are the diagrams that shows how we can read the data from the memory. This is enhanced dynamic RAM, that is a advanced part of the dynamic RAM. These are the multiple conventional dynamic RAM, that is fast base mode dynamic RAM, that is FPM dynamic RAM. Extended data out dynamic RAM, that is EDO dynamic RAM. Then synchronous dynamic RAM, double data rate dynamic RAM. These are the categories of dynamic RAM also. Then non-volatile memory, that is when the light has gone, the data will be finished or data will be vanished from the memory. This is a flash memory. As we have discussed about the types of ROM, that is programmable ROM, erasable ROM, that is double ROM, that is electrically erasable ROM, that is double EEPROM. Then flash memory. Then how to access the main memory? By using the electrical conduits, that is known as the buses. That is, bus are used for communication from the CPU to the memory. This is your bus structure that connects the CPU and the main memory. This is how it connects the CPU and the main memory. These are the buses. This is a bus. This is a bus. This is a bus. This is also a bus. This is a memory bus. This is memory bus. This is system bus. This is the bus interface. This is also a bus. So that's all for today's session. Now, if you have any doubts, then please text the doubt and I will answer you. So that's all.